I make it about 10 past. I can't see a clock anywhere, so I'm just having to go on my watch here. About 10 past? Yes. Yeah, good. In which case, let's go. Closure's the next big thing in Java was the title. And I submitted this before I realized Brian Gertz was going to give my talk as a keynote yesterday. So I thought, do I rewrite it last night? I thought, no. The Atlassian wine was too nice. So I've had a quick hack at it this morning to try and make it different to what Brian Gertz was telling us about. And the first difference is to say, well, actually, this is a question, not a statement. Is closures the next big thing in Java, rather than trying to claim it is? So what I've tried to do here is to say there is going to be a big change in the way we write Java in Java 8, and everything we knew about idiomatic Java will change. And the last point here, survived to the end of the session, is because I'm going to be contentious. And so I'm going to hide behind here just in case some tomatoes come this way. Anybody? Yeah, some people are laughing, that's good. We've got to have some humor here. Structure, well, there. So, what are we going to do here? How many people are actually using Java 8? Java 7? Java 6? Java 5? 4? Well, 1.4. And then, of course, there's all those people still using Java 1.1.8. They're all out there doing Java ME. Why are they still using 1.4? Because moving to generics is too painful. And there is absolutely nothing else in Java 5. And generics were, well, rubbish. They should be erased. It was too big a barrier for them. They didn't see the benefit of anything in Java 5, and so stay with Java 1.4. And the 7 to 8 is a far, far bigger change. It's much more disruptive because it's going to change the way we think on the JVM. Or it could be that Java is changing so fast and nobody is adopting it anymore, because we had a spread there, quite a lot of people using 7, quite a lot of people using 6, and of course 6 is now a dead version, or at least it will be in November. And we're 1 or 2 people using 5, well beyond end of life. Why are people using those versions? Because they don't care about the progression of Java and where it's going. So could it be that Java's, the future of Java is just to be a dead end? Well, my position really is that Java currently is using lots and lots of 1970s programming techniques and hasn't really progressed very far. And what we need to do is progress by looking at how to use 1930s techniques. And there's these 4 chaps who did some splendid work on how to do computation in mathematics. They didn't bother with programming languages and computers. They're interested in doing computation in mathematics. And they're very successful. Probably most people might well have heard of Turing. Yeah, good. And Church and Clean. There's a whole crew. These are just the 4 big names because they have theorems named after them. What we really want to do, of course, is to have an opportunity to do some 1990s programming. Object-oriented. So how many people think that Java is an object-oriented language? A few. My thesis, as it were, is that Java is an imperative procedural language. It just happens to have some classes. It is not object-oriented. We'll see an example of some code in a moment. So I'm hoping that with Java 8, we finally get to do object-oriented programming. Oh, beginning, middle, end. Beginning, other beginning. Right. What is a closure? I ought to perhaps just put on record, as it were, my thinking of what a closure is, and we get a statement looking roughly like this. that it's a function. Well, that's dead end for Java because Java doesn't have functions. We only have methods because Java's supposed to be object-oriented, and object-oriented things don't have functions, they have methods. So we've already got a problem here. So a closure is a function associated with an environment. An environment basically just a map of some sort that gives us a mapping of names to values. So that function has no free variables. So here's an example of a piece of code, and we've got ourselves a free variable here. This return x, well, x is the parameter, so that's got a binding, that's not a free variable. The y is undefined within the function, and so that tells us what a free variable is. Y here, one heck of a free variable, how do we bind it? And until now, the history of how we bind that in Java has been a bit of a pain, as Brian Gertz pointed out in his keynote. I also want to introduce a term, referential transparency, because we're supposed to be thinking functionally, and functional programmers love referential transparency. Why is that? Because of these mathematical functions. So it's back to this mathematics view of computation. A function maps a value to another value. And in particular, f of 1, if it maps to 2, then f of 1 will always map to 2, no matter when you call it. Now, in programming, of course, we avoid that as much as possible by having state. So that f of 1 might give 2, or it might give 7, or it might give 63. This is the nature of having state within the functions. So the idea of referential transparency is to avoid those stateful activities. So when you apply a function to a value, you know you will get a specific value back, always. And that's at the core of the functional programming viewpoint. You're thinking, well, at least since 1.2-ish, 1.1-ish, Java's had sort of closures if you do a bit of a mind think, in that if you've got a class with a single method and single assignment fields in that class, and you've got something that can behave a bit like a closure. So here's a bit of code, closure class, it's got a final integer field. I like final. How many people put final on their variables first and then take it away if they have to? Excellent. We like each other. Good idiom. So here we have our state, if you like. For an instance of this class, we'll have some state, but because it's final, it's a single assignment. Once assigned, it will never change. So we're enhancing the idea of referential transparency here. We have the constructor so that we can provide a value for that, and then we've got our single function that will do something. And we could make use of that looking something like this. Mutter, mutter, mumble, mumble. And Java 8 isn't going to solve this one, by the way, as a footnote. So grumble, grumble. I suppose, given the last talk, I ought to write a blog and moan, but I'm doing it here. We'll have I think my battery's running out. Yeah, I'll have a moan about that in a minute. But we're creating instances of objects that have one function that can be called. State is fixed, referential transparency, love it. But it's not great syntax. And also, aren't we told, oh, you must program to interfaces? So let's do it with interfaces instead. And here we have an interface up here with the method, and we're still going to be using that in Java 8 and so on and so forth. So hang on to that one. And here we've got instantiating an anonymous class to a specific interface. The sort of thing we've all been doing for the last 15 years, I guess. Yeah? Yeah, some people have. But you still end up multiplying by 5, but you have to call it. Annoying, annoying. But of course, Java eschewed operator overloading because C++ folks liked it. and Python folks liked it, and Groovy folks liked it. Oh, that comes after Java, of course. But well, simplicity, I guess. But it would have been nice if these languages had convinced the Java folks to include it, because then you can do things like this. So, which language? Any thoughts which language this one is? No. Okay, Groovy. So, you know, we have a variable refers to a lambda function, has one parameter. Groovy has this wonderful feature. If you've got a function of one parameter, you can ignore it and just call it, which is going one step further than Scala and everyone else, and indeed one step further than the Java 8 proposal. But look here, no dot call. You can do dot call if you want, but the point is this operator is being overloaded. The open parenthesis is a message to the object referred to by multiply by 5 saying do something. And that object will then interpret that message saying, oh, well, I'm actually going to do this. I'm going to call that function. So this function here will then get executed with the parameter 4. We get back the value 20. Lots of stuff there. Perhaps this one's more obvious to people. Which language? Scala, yes. So they have this idea of we can have a variable that's a function, and it has a body, it returns a value, and then they stick in int and int and hope that the compiler does some type checking. But again, we've got the open parenthesis is a message to the object referred to by multiply by 5, and it's up to the object to determine what that means. It's not up to us, the coder, to determine what that means. And Java 8 is going to be able to do stuff a bit like this. So you get something looking like that. Cool. Looks just like Groovy, which is Groovy. Not entirely keen on this myself, but then I'm quite happily into dynamic typing. But it works for me. This bit does not. But we can sort of hide that and double think our way through it. And we're beginning to get some interesting ways forward. So if that's all there was, it's nothing revolutionary. So why is there this revolution coming in Java 8? And it's because the lambda expressions are just the tip of the iceberg. They're just the bit you see. They get rid of all that messy anonymous classes, and it simplifies the syntax, which is good. So you can focus on the semantics of it. But it's not that that's going to cause the revolution. The revolution comes with the next bit. And it's all about where the iteration is. So let's pin this really on this dichotomy. Should iteration be explicit or implicit in terms of the code we as application programmers write? And so to try and highlight this as sort of example, so here we are, calculate the sum of squares of the numbers 0 to 100 that are divisible by 7. It's just a trivial little one-liner to try and give us an example on which to pin some of these ideas. So how many people in Java would write something looking like this? I think 60, 70, 80% of Java programmers, given that first statement, would end up with something like this. We create ourselves a list, we're good people, we instantiate with a class, and we have variables of the interface, and iterate over numbers, thinking of which ones are going to add, and then we iterate over them and do some more summations, and aren't we good people? And my God, this is C written in Java syntax. There is absolutely nothing object-oriented about this. This is procedural programming. And if we're supposed to be doing 1990s rather than 1970s programming, why are we writing this sort of rubbish? And I bet you're seeing lots of this sort of rubbish. You may not write it, but your colleagues might be writing it. So what do we want to be able to do? Well, let's have a look at those other languages again. So, which one's this? No, okay, Scala. It's all iteration going on here. The 4. So we've got a 4 here. That looks a bit iteration explicit. Selections yielding something. Ooh, dot sum. Hint of something interesting going on here. We are asking an object to do something. We're sort of sending a message in, requesting some activity. We are hiding some iteration within that sum. We are asking the object to do some work for us, rather than telling it what we're going to do. Let's take it one stage further. Switch languages. Any volunteers as to which one this one is? No? Okay, Python. It will actually run, if you've got Python, it will run on the JVM. What's interesting about this one? Well, they've got these generator expressions that can be filtered. They're great, providing iterables, but it's still explicit iteration in a sense. But now we're applying a function sum. We're saying we have an abstraction out of the library that hides the iteration. The iteration is implicit, not explicit. So the sum can be applied doing the work for us. Back to Scala. We know this is Scala because they've got the wrong symbol here. Far too many horizontal lines for my taste. But a more important thing has happened here. We've completely removed explicit iteration. We're saying we have a data structure, 0 until 100. And then on that data structure, we ask for the filter operation. We are sending a message from our code to the object, asking for some activity to happen. This is 1990s object orientation. Implicit iteration. The object is responsible for interpreting what the term filter means. We pass in one of these lambda expressions, and it's used very much strategy pattern going on here. So if we go back to gang of 4 patterns, we're finally implementing strategy in Java and Scala and other such languages. Having filtered it, we then map it so that the filter selects some items. We've still got a data structure. Map applies a function, this I-squaring, to all of the elements in the incoming data structure and delivers up a new data structure which we then apply sum to. So we're using symbols that hide iteration and provide strategy-like the functions for the iteration to apply. We can handle this in Groovy. Okay, so the names have changed because Groovy had a bit too much small talk influence. So things like collect rather than map, but it's the same function. It's mapping a function across all the elements in a data structure. The iteration is implicit rather than explicit. Slightly different syntax to create the sequence 0 to 99. So it's just 0 dot dot 100 instead of 0 until 100. But that's just a minor matter of syntax. The commonality there is that we have a syntactic representation of a range of values that we could put down. This is just the same one without all those messy arrows, with the implicit one parameter, and we'll just call it it. This is turning out to be very idiomatic in Groovy. I'll go back a slide. This is perhaps more technically correct if you're thinking in terms, I am passing a function into another function. But idiomatically, Groovy programmers do write this, and it is smaller, and to be honest, it is easier to read. And you just get used to having it all around the place. Oh, so what language have we got here? Yes, Java 8. We have finally arrived at Java. So we have some reference to some data structure. We are filtering that data structure with this lambda expression, map it with a lambda expression, then we reduce it. Map, reduce, heard of that before. But not with a capital M and not with a capital R, because that would be a trademark. And that would be something completely different. But we are doing map, reduce. It's a scatter, gather activity. I guess why my down here? And that's really because what is this numbers? How have we created this range? And why do we have to use reduce? Why haven't we got a method sum? Well, I don't know. Perhaps sum ought to be in there as well. But reduce is really a function that operates on the data structure that results from its things. This is the initial value, and this is the function it applies to each member of the data structure provided in. So you take a list, and you basically, in this case, we're adding, so you create a cumulative total. You iterate over the data structure. So again, it's an internal iteration rather than external iteration. But we've got this very fluent interface. So the data structure, we apply a method, we return the data structure. We apply a method, we return the data structure. Apply a method, return the data structure. Very, very common idiom since the beginning of time in functional programming. And to be honest, it should have been the correct idiom in object-oriented programming, because this is object-oriented programming. Not that stuff we saw before with for loops. That was C. Well, we've got the on this one. In the end, the reduce. What about the on the numbers? I'd like to find out a way of creating the range 0 to 100 in Java without doing this. So please, if someone knows how to get 0 to 100 in Java without doing that, I would like to know. That for me is beyond ugly. It's horrible. I want 0.100, which is why I've got Groovy. What is this all about? It's all about higher order functions. Well, that's the, I was about to say pretentious, functional programming viewpoint of it, the mathematics viewpoint of it. What's a higher order function? It's a function that either takes a parameter which is itself a function or delivers a value that is a function. And we're actually quite used to doing this in Java and other languages, Scala. We just weren't thinking of it in those terms. And his map function, the filter or method I should call it, the map method, the filter method, the reduce method, the sum method, all of these are effectively higher order functions. We have to slightly change our language in terms of method and function, but we can get away with treating these as higher order functions. So, higher order functions take or deliver another function. You're sitting there thinking, yeah, why do I care? And of course, you can express the fact that, remember starting at the beginning, nothing new and interesting has happened to Java since 1.4.2. And certainly this guy doesn't care. Why do we care? Because all computers are parallel computers. Now, how many people have got a phone with only one core in it? How many people have got a phone that has more power than a Cray 1? Exactly. It may surprise some people to know that you might have a 64-core chip in your phone. It's the one doing all the digital signal processing. Nothing to do with the screen. They like grid computing, 8x8 squares to do all these sorts of things, and they're quite cheap. So we've got all these computers around, they're all parallel. What's the payback? Well, of course, this guy still doesn't give a damn. But we have to. We have to move our mindset from being 1950s which says one processor, one computer, one thread, one program. If you look at what we're all doing in programming, most people still are in that mindset. Anybody doing shared memory multi-threading is still thinking in the mindset of, I have a 1950s computer with one processor and I'm going to have to time division multiplex it. We've got to move away from that. We've got to assume that the computer underneath us is a parallel computer. Moreover, we have to give up this idea that we're not doing object-oriented programming, and we have to do a bit more functional programming. And we have to avoid claiming that we're doing object-oriented programming when in fact we're writing C in Java syntax. So, for me, this is the killer line for Java 8. The reason it's interesting is because I have made one change to this program and all of a sudden it is parallel capable. Because the data structure that we have here, however we've actually constructed the thing, the reference to the data structure that we have here can now be asked to work with a thread pool. The thread pool is underneath. We don't manage it. We don't care. We let the infrastructure manage itself. What we care about is it uses every core that's out there. And that program will do it, except it doesn't work, at least not last week. I have the JDK8 lambda, and the parallel function does not work as yet, which is a bit sad. I am sure it will work. It has to work, because otherwise Java 8 will be a failure. For me, this function is the difference between Java being a dead language and Java 8 being a resurgence of the Java language. Enter the fact that we can still do this in Java 6. So if you want to go out there and start programming like this with Java 6 and Java 7, you can do it today. You just get gpars, which is a small little jar. You get groovy all, which is a little bit bigger. You put them into your class path, and you can do this stuff. You can do it today, very successfully. And if you're hyper cool like me, thank you, you actually use Groovy 2.1 snapshot, and you discover that this code runs as fast as Java because of invoke dynamic. I think there's a sideline here that we're going to have to get rid of this idea that dynamic languages are slow. In some situations, yes, they are. But when you're doing computational stuff, where the JITs and the invoke dynamic can get in there very quickly, you discover that dynamically typed languages execute as fast as statically typed languages like Java and Scala. And this isn't just me waffling. If anybody wants to challenge that statement, then let's coffee break, I will run the codes on here. And we'll see that Java will go at about 8.9 seconds, and the Groovy will go at about 9 seconds, which, for the difference between dynamic and static, has changed the game. And you're thinking, oh, don't like these names. We've got names for that already. And why do we have to explicitly parallelize everything? Well, no, we don't. So gpars has alternate namings. The issue here is, do you fit with the groovy naming, or do you fit with the traditional functional programming labels that come out? And so for the people coming from groovy through into gpars, we've got the groovy style naming. For people coming from other functional programming languages, we've got the traditional naming, as you see here, and that looks like Java 8. Very, very close to what's going to happen in Java 8, and we can do it last year instead of having to wait. So if you want to stay with Java, that's fine. But if you want to practice the sorts of programming approach, then we can do it today, even without the JDK8 lambda. Ooh, here's a neat trick. Let's just say we always want this data structure to work in parallel. So it's parallel data structures. Underneath, we're using JSR 16, well, we're using extra 166Y, which isn't actually going to make it into Java, sadly. The parallel array, Doug's given up on it and wants to do a slightly different data structure. So what we've done for GPARS is we've forked extra 166Y, so it's there, and no matter what happens. So this will work in perpetuity based on the 166Y stuff. I like it. It's the right way of doing parallel programming. And this is just using it rather than full labeled parameters. So the sales plug is really that GPARS and Groovy can give you today, even if you're only on JDK 6, the sorts of programming style that Java 8 is effectively going to mandate for Java programmers. I guess you could have a look at things like Guava, Totally Lazy, Functional Java. Guava, I haven't really come to terms with. Totally Lazy is really cool, but it's not going to be mainstream, I suspect. Functional Java recreated the whole collections library, and that was not the way to ensure your future as a library. So I don't think functional Java will make it mainstream, but it's an interesting thing to go and have a look at and go and play with to understand the style of programming that Java 8 is going to lead us towards. Or you could get really, I was about to say really dangerous. How many people remember Saturday Night and Dangerous Brothers? And no, these jokes are going to fall flat because Ade Edmondson and Rick Mail did a whole load of really great sketches and nearly killed themselves on 3 separate occasions doing those sketches because they were the Dangerous Brothers. Well, you could be a dangerous Java programmer and get in there and get the JDK 8 lambda release and see what falls over. Surprisingly little. I was quite amazed. Or you could wimp out and just go to Scala and say Java's a dead language. You know, it's legacy, Scala's the way forward, and we can have that warfare somewhere else. I prefer to be collaborative rather than confrontational, despite the way I present. So this is the Scala version of doing the same thing. Spot the idiomatic similarity, data structure, marker that says it's no longer sequential, but it's parallel, and then the application of function. You are sending messages to objects. We are finally seeing some object-oriented programming. So, beginning to wrap this up, I've gone a little bit quicker than I anticipated. Java 7 to Java 8 is claimed to be the introduction of functional programming. That's just waffle to try and get the functional programmers on board. What it is really, it's about getting us to be object-oriented. It's about getting us to send messages to objects. Tell, don't ask, I think was a phrase that someone coined some time back. The object is responsible for its own behavior. Therefore, iteration should be the responsibility of the data structure, not of us. Implicit iteration is better than explicit iteration. So these languages have pioneered the way. Java is, in some sense, following, but Java is the language of the majority of the people on the JVM. So I suspect in 6 years' time, everybody will be using the techniques of Scala, Groovy, Python, C++, except perhaps operator overloading. That's a battle to be had, I guess. But we will still be programming in Java, I bet. But we will be programming in Java in a way that looks like people programming in these languages today. And really the take-home message is it's about how your data evolves. We should give up being interested in control flow. I asked this question yesterday. How many people, when they're programming Java, worry about the stack? even fewer than yesterday. How many people worry about their heap? Sort of, yeah. But do you worry about the structure of the heap or just the size of it or the garbage collection? It's very high-level properties of the heap. You don't care about, is this item of data in this location? Some of the C++ folk do, and certainly in embedded situations, you have to be more concerned about that. But the average Java programmer, let's be honest, doesn't care. They leave it to the runtime system to manage the heap. So why are we so obsessed with control flow and threads? Why do we want to be in control of those threads? I don't. I want to let the thread pool handle it. It's infrastructure. I'm a great fan of having the implicit iteration, of sending messages to the object. So less control flow, more worry about how our data evolves. The filter, the map, the sum. We're applying operations to manage the way in which our data evolves. A simple example to go on a slide is indicative of the bigger, wider context. So, send messages to your objects. Don't assume you have to grab data. Or put it another way, the Beans protocol was a waste of time and effort because it was all about us controlling the values in data structures. Higher level operations, implicit iteration. So to get to the question, closure, the next big thing in Java. Will it be that? Well, this guy doesn't care. He just wants to be fed. And of course, squirrels deny parallelism. They really just don't care. Not even this one. But we have to care. And so closures, these functions that are going to be flying around in our Java code instead of us worrying about anonymous classes. Yes, I think they're crucial. On the other hand, no. Closures really don't matter to the importance of Java 8. It's not the lambda expressions that make Java 8 a disruptive, revolutionary force. It's the library change. It's the shift of the data structures from being static things to being properly objects. Okay, so the defender methods on the interfaces are the way that that's going to be handled. That's just technology. It's the idioms of the way in which we program that are going to change. It's this technology. It's the libraries that are going to change our thought. They are the revolution. And with that, I shall quit. If anybody has any questions, then yes, sir.
I don't care about this parallel execution. So either I should exactly know what this means, or otherwise I don't bother and I don't want to state it explicitly.
Yeah, the question here is why should we be putting any explicit notion of parallelism into our code at all, that we should perhaps put the parallelism, like the control flow, into the underlying infrastructure. And there is a strong argument for doing that. The question is whether the algorithms we write are sequential or can support parallelism. I think for the moment we have to allow a bit of flexibility because the idioms we're used to for the last 40 years have been sequential programming idioms. We're now looking to really allow all our software to be parallel. We don't know what the best idioms are. We don't know the effect on our algorithms of having huge amounts of parallelism. If we go to the HPC community, they've got massive C++ and Fortran libraries, and they just use them from Python. And they don't care about parallelism because it's hidden from them. So they've raised the level of their library up one. Now, on the JVM, we haven't got that far yet. So I think we need that flexibility just to say, I want this to be sequential. I want this to be parallelized. You get on with doing the parallelism. But in the end, I think our programming languages should just work underneath, and we should be expressing much higher level statements of desire than process. So does that cover your question? Cool. Any others out there? No? In which case, I and the squirrels, thank you. And remember, squirrels deny parallelism. Thank you very much.